The chair has three main objectives. First, to conduct research on multimorbidities, multiple cause of death, mortality forecasting, especially in the context of the COVID-19 pandemic, and to develop innovative demographic model for mortality analysis. The second objective is to supervise PhD students, and the third one is to disseminate knowledge. For the last two objectives, chair members have been actively involved in conferences, both through attendance and presentation, and we are supervising a PhD student. Regarding the first and principal objective of the chair, we are currently working on various topics covered by the chair. For this first year, we were particularly active in analyzing multiple cause of death pattern. This approach, which considers all contributing cause rather than just the primary underlying cause of death, aims to deepen our understanding of the condition leading to death and enhance mortality analysis. While the vast majority of death certificates record multiple causes of death, especially in cases involving older individuals, this reflects the fact that several diseases often contribute to a single death. Focusing only on the underlying cause, which is the condition identified as initiating the chain of events leading to death, can overlook a significant role of other contributing conditions. For example, in a study using US data, we found that only looking at the underlying cause of death significantly underestimate the role of heart disease, mental illness, respiratory disease, and metabolic disorders in mortality. We also look at the role of each disease based on its position in the death certificate. For instance, heart disease and neoplasm are often recorded as the underlying cause, while infectious disease are more often cited as the immediate cause, which is the cause occurring at the end of the morbid sequence. Meanwhile, mental and behavioral disorders are more often listed as the contributing factors. We also look at the estimated potential gain in life expectancy we could achieve by eliminating specific disease and specific role using cause-eliminating life table. A significant part of our research also focused on looking at the association and dependencies between different causes of death. For example, heart disease and endocrine, nutritional, and metabolic disorders, which include diabetes, often show a strong association. However, our analysis for US data revealed that these dependencies are more complex than previously understood. Many causes are often interconnected, meaning that if the dependencies between two specific causes were altered, it would impact dependencies across a lot of other causes as well. So several studies are currently underway. For example, we are currently analyzing trend in diversity of cause of death, finding that causes have become increasingly varied over time, especially when we consider multiple causes of death. Using data for US and Denmark, and we also collaborate with other researchers to obtain data for other European countries, we want to extend these findings. In addition, we are quantifying the probability of dying from one specific disease before another, and exploring the causal interrelationship between causes of death. One compelling ongoing project look at the reliability of multiple cause of death data. So using Danish registry data, we can track individual disease histories to assess how accurately this condition are reflected on the death certificate. We are also conducting research on how COVID-19 will impact cohort mortality in the long term, and how the height of the mortality peaks after the COVID-19 shock determines the time to recovery to a new stable pattern. In the third and last topic, we are working on finding optimal methods to study the link between cause-specific and premature and senescent mortality.